I am really thrilled and honored to be with CARTA today. The topic that was given to me by Pascal Gagnon, the human brain in its usual extraordinary and compromised states, is perfect. What I will do is tell two different stories that I think reflect upon our evolution as a species. One is about the upregulation of artistic creativity in a subset of patients with frontotemporal dementia. And after that, I'm going to describe the loss of our social brain functions as we descend into the degeneration of frontotemporal dementia. I think both stories give us insights into the parts of the brain that evolved in late Homo sapiens that allowed us to create visual art and to live together in large groups. So there's a story across the world, Lascaux in Europe, this incredible cave painting in Colombia, recently discovered. The story is really both beautiful and simple, and that is human beings, wherever they lived, began creating art about 40 to 50,000 years ago. The art was spectacular, precise, vibrant, and had never appeared like that on the planet before. It really strongly suggests that there was a change in the human brain that allowed, I think I would even say mandated, that we create art. And I think lots of questions about where in the brain that happened. And I'm going to tell you a little story about visual creativity in the setting of frontotemporal dementia. So I began to realize this when I was at UCLA. Visual creativity in frontotemporal dementia is not rare. I would say it's common in certain subtypes. People with FTD develop new artistic skills even after the onset of a degenerative disease. Remarkable. As the brain is suffering from progressive degeneration, there is this emergence of something quite extraordinary with visual creativity. It's more common, and I'll touch on this much more, when the anterior temporal lobes or the left frontal lobe show focal degeneration. My first paper on this was in 1996, but began to document this story. Many people, when I started writing about this, said this is a coincidence. It is not a coincidence. Like almost everything with human behavior, it's driven by the upregulation of very specific circuits in the brain. So one of the groups, and I'll come back to this again and again, that is particularly prone to visual creativity, this uniquely Homo sapiens capacity, are patients with a diagnosis of the semantic variant of progressive aphasia. These people have profound deficits in naming. Not only can't they name, but they also lose the ability to understand the meaning of words. So they lose the understanding of single words. They have impaired knowledge about objects. What is that? Not only do they lose the name, they lose the concept of that object. They have very specific features with writing and reading. They tend to spare repetition and speech production. So the theme in this subset of patients with frontotemporal dementia is left temporal, particularly anterior temporal lobe degeneration. Very focal. Other parts of the brain are allowed to continue to function. And as I'll argue, some areas increase the activity, allowing this unique visual creativity. Here's an example of a patient with a semantic variant of primary progressive aphasia. She's attempting to name simple objects like apple, rabbit, sled, can, and frog. And you can see her absolute befuddlement as she tries to go through this naming exercise.
Is that a vegetable, a fruit?
A fruit, but doesn't call it an apple.
Dog?
Doesn't know what a rabbit is.
I don't know what that is.
Doesn't know what a sled is.
Can?
Gets a garbage can. And I think this is quite remarkable here.
Cat?
Cat. Okay, so the very concept of frog has
Fruit?
claws. Okay,
The cup.
good.
A cup?
That's right.
Let me show some more naming. She gets the cup.
Matches.
Matches.
Well done.
Doesn't know what matches
Which one
are.
is the matches?
I don't know what the matches are.
Okay, so very focal deficit
Flowers.
in naming. One of the things that I've documented over many years is the beginning in Lancet in 1996 is the emergence of visual creativity. These people become visually obsessed with their world, and they use whatever artistic capacity they have to create objects or paintings that reflect the environment as they see it. This is one of my patients who became remarkably visually creative. He was a welder and never had done anything with welding before in the artistic area. And this is his representation of a bird, has many features of an insect that shows this semantic confusion, but the use of color, shape, and form, I think, is truly extraordinary. I own this piece and I look at it every day. It's wonderful. Here's one of the people that we have written about extensively, and this is the brilliant scientist Ann Adams, who, in the setting of a progressive loss of language, began to create unbelievable paintings. This is Anne's masterpiece, written a few years before she manifested with progressive aphasia. She became obsessed with Ravel's Bolero, the repetition, the crescendo, the lack of change until the 323rd meter, where there was gaudy fluorescent pinks that represent the change in key. So Anne became obsessed with Ravel, in particular this piece that Ravel described as an experiment in sound, but not true music. So a few years later, Anne had evidence for progressive aphasia. Bill Seeley from our group was able to compare Anne Adams' brain at the time that she produced Unraveled with the brains of 30 age-matched control women, very high education like Anne. And the remarkable story is just before Anne developed progressive aphasia, she showed massive atrophy in the left fronto-opercular region, statistically different than 30 age-matched controls, but also increased volume, yes, increased volume in the regions of the brain that I think are critical for the creation of art, the right posterior, parietal, temporal, and occipital regions. So the brain is reshaping with this degenerative disease as one circuit turns down. The back of the brain, particularly on the right, becomes overactive and becomes visually obsessed and creates a series of magnificent paintings. This is the last example of Anne's work. Her husband took her in 2004, this point having trouble with the right hand, completely mute, and asked her to enjoy this city in Belgium, Ghent. The picture that she made on the left, remarkably, she made this after she returned, no pictures, nothing, looks remarkably like the picture that Robert Adams had taken of Ghent, and remembered this, reimagined it, and replicated into a gorgeous painting on canvas. This is the artist that really changed the way Bill Seeley and I think about art and the brain. One of the most remarkable aspects of this story is that Maurice Ravel, who created Bolero, developed progressive aphasia just before he created his masterpiece, Bolero. So these two people separated by almost a century, locked together with the same neurodegenerative disease. We believe Anne would never have created art if the progressive aphasia had not happened. Similarly, Ravel would never have produced Bolero if he was not suffering from this focal degeneration in the left front of the brain that released posterior circuits involved with his creativity. This story has been put into a play that showed at the Annenberg Center in Los Angeles. We'll soon tour across the country. It's a beautiful story of Ravel and Adams, the uniqueness of human creativity, and it shows the story of Anne as her artistic ability evolved. Adit Freeberg, along with Bill Seeley and I, looked at all of the artists that we had ever seen in whom we documented visual creativity. I think this vastly underestimates the number of people who became visually preoccupied or creative in our setting. But we found that about 2.5% of our FTD spectrum patients had developed visual creativity in the setting of degenerative disease. This just is extremely rare, almost never occurs in Alzheimer's disease. Even more remarkably, almost 7% of the artists had this semantic variant of frontotemporal dementia, which I gave you an example of a few slides earlier. In most of these people, the artistic creativity was de novo. 7 of the 17 had some prior interest, and there were only 2 people who were actually artists before the onset of the disease, and their work dramatically changed, we think, for the better. What did we find in our artists? Severe atrophy in the anterior temporal lobe, amygdala, left side in particular, ventral striatum and insula. So a very specific focal degeneration in a language circuit. All of the patients with FTD, and you can see this, had upregulation in posterior circuits. But the thing that separated the artists from those who did not become artists was strong correlation between the left motor strip and this posterior dorsal parietal occipital region. So the summary of these artists was the visual creativity occurred early in FTD, strongly associated with degeneration of the anterior temporal lobe. And we think that this suggests that damaged regions normally suppress dorsal medial occipital cortical circuits. And when you lose those regions, there is increased curiosity, activity in the visual cortex. And in many people, it actually leads to artistic creativity. This is the region that we need for visual creativity, posterior brain, in particular, right more than left. What did the art look like? Bright colors, rarely focused on human faces, no surprise. Anterior temporal lobes process human faces. You can see these gorgeous animals, cartoons, motor car. 2 of the semantic variant PPA patients generated animal sculpture, but lacking the features of the species. You saw the bird. And when facial expressions were present, they were bizarre, did not convey normal emotions. So the art is unique in the vibrance of its colors, but also in the lack of human faces and emotion. Okay, that's one story. The second story is social decline in behavioral variant frontotemporal dementia. Around 40 to 50,000 years ago, we humans began to live in larger and larger groups. Eventually, by 10,000 years ago, we had large societies where people lived, worked together, developed rules, and needed very strong circuitry that I call social brain. What do we see in behavioral variant frontotemporal dementia? Loss of altruism, loss of emotional regulation, loss of empathy, inappropriate behavior toward others, and loss of the human characteristic that allowed us to live in large groups. This disappeared. One of the stories that Bill Seeley has developed is the story of these phylogenetically new neurons, von Economo neurons. They are largely a feature of big brain social species, elephants, the cetaceans, and the great apes. We have far more of these von Economo neurons than our nearest relative, the bonobo chimp. This is a feature in particular of right frontoinsular brain. We have twice as many of these von Economo neurons in the right side of the brain, which is strongly devoted to social behavior, than we do on the left. One of the features of these animals that have von Economo neurons is they have theory of mind. They can look at their own face in a mirror and recognize that that is me. This is one aspect of this social cognition. How am I different from others? How do I treat others? These are the things that soon follow. So as we have learned, the von Economo neuron count is normal in Alzheimer's disease and, of course, in healthy controls. In frontotemporal dementia, profound loss of von Economo neurons and the related fork neurons. Not only does this happen in FTD, we think in behavioral variant FTD, it is usually the first neuron to die. So a phylogenetically new neuron involved with social cognition is lost, then we lose our capacity to interact in an altruistic way with others. What happens when von Economo neurons are lost? We lose social brain circuits, we lose theory of mind, we lose altruism, we lose empathy, we lose emotional regulation, we lose this social brain capacity that evolved late in our species. So my conclusions: art emerges with Homo sapiens, changes in posterior parietal regions, posterior temporal regions. I think that must explain the difference between our species and prior Homo species. The artistic creativity emerges in association with left hemisphere dysfunction, particularly left temporal. This leads to rewiring of posterior brain, upregulating circuits that we need to develop art. Social brain emerges with Homo sapiens evolution. We lose social brain with behavioral variant frontotemporal dementia. This correlates loss of new neurons, the von Economo neurons in the right frontal region. This story gives us insight into the degenerative process, which is very focal and gives insights into our humanity. And I think one of the things I've learned from this story is that brain asymmetry is both at the core of our strengths and weaknesses. Thank you.